Beautiful.
Oh, look at that. Get a shot of that. We were just blown away. It looked as if someone had spilled blue-green paint across the surface of the lake. The smell it was giving off was like a musty, dying plant. And you could just visually tell while paddling that you were pushing through a dense layer of cyanobacteria.
When we wrote the Wilderness Lakes project for the trust fund, I assumed we'd see mild algae blooms. But what we saw, 2 portages into the boundary waters, was akin to some of the most polluted systems in the world.
Algae are essential to every aquatic system. They form the base of the aquatic food web. There are tens of thousands of different species of these single-celled photosynthetic organisms. This community of algae becomes problematic when dominated by cyanobacteria that act like algae but have the potential to form toxins, which can negatively impact the food web. And it's a public health concern because they can make people and pets ill.
When we think of harmful algal blooms, we think of systems in urban environments that are receiving stormwater or wastewater pollution, or agricultural areas that are getting fertilizer pollution. We never think of algae blooms in pristine, remote lakes. We immediately started to hypothesize, how could this happen? Could it be ash from forest fires? Could it be soil particles laced in fertilizer blowing in from the Red River Valley? Could it be that lakes are warming up the fastest in our northern latitudes?
With the support of the Environment and Natural Resources Trust Fund, we were able to conduct 1 year of full monitoring within the boundary waters and the Superior National Forest. We deployed buoys that continuously monitored lake temperature and oxygen every 10 minutes throughout the entire water column. We paired that with atmospheric deposition sampling, monitoring devices that would collect dust material, not just rain and snow. These approaches were really novel in this area because remote wilderness systems are not often monitored to this extent.
Using lake sediments, we reconstructed the abundance of these algae through time to look at the different groups of algae depending on their own pigments. We also measured the DNA to get an idea of how toxic these blooms are. Are they worse now than they were 10 years ago, 50 years ago, 150 years ago?
We traveled to the boundary waters once a month for 5 months, backpacking in hundreds of pounds of gear, portaging canoes, fighting through clouds of mosquitoes. We went on a winter coring trip in which we had to pull all of our scientific sampling gear on sleds across frozen lakes. It was an intense experience that resulted in a really unique and amazing data set.
What we've seen consistently across every lake that bloomed, which were marginally deep, between 15 and 20 feet, is the separation of the lake into 2 layers, much earlier in the spring.
Minnesotans may be familiar with the idea that as you swim deeper into a lake, you might experience a much colder layer of water. And that separation in temperature is what keeps water with nutrient-rich sediments at the bottom of the lake and warmer water where algae can grow at the top.
The layers that don't exchange gases with one another, leading to a drawdown in oxygen in that bottom layer, leading to this pump of phosphorus from the sediments, the nutrient we're worried about in stimulating blooms, and then a premature mixing of the lakes. When the water is still super warm, there's still plenty of time to produce harmful algae.
Through the support of the Trust Fund, we were able to identify the main driver of these harmful algal blooms as temperature change. So as the atmosphere continues to warm, lakes that fall within this specific range of depths, and not just these wilderness lakes, could undergo this mixing phenomenon.
Before we publish our results, we bring it directly to the public to get their feedback, which goes hand in hand with what the trust fund is trying to do. We've had lots of people contacting us like, hey, come look at our lake. Do you think this is what's going on here? And so I think this was much more widespread than we imagined.
This work is important to Minnesotans because our identity relies on high water quality to enjoy our lakes going into the future.
This is still a very active study, but I think the important message that needs to come out of studies like this is that climate change is not a future issue in places like Minnesota. It's a now issue. We're already starting to see things that we really care about fundamentally change.